Hi, my name is Anna Hood. This is my map story on 2020 vessel traffic and marine habitats. Vessels interfere with marine ecosystems in a number of ways. Marine mammals in particular are vulnerable to impacts of high vessel traffic. This map story has three different sections, the first one covering large cetaceans of the West Coast. All marine mammals are protected under the U.S. Marine Mammal Protection Act. Cetaceans are an order of marine mammal that includes whales, dolphins, and porpoises. Some of the cetaceans that inhabit the West Coast are blue whales, gray whales, humpback whales, and harbor porpoises. I have photos or artistic drawings of each of those. Here we have our blue whale. These links up in the corner will take the audience to the NOAA Fisheries page on each of these species just by clicking on the link. Okay, species distributions and protections. Blue whales are listed as endangered by the IUCN Red List of Threatened Species. Once again, here's a link to take the viewer to that website, the IUCN Red List website. Only one distinct population segment of gray whales migrates along the U.S. West Coast, which is actually the eastern coast of the Pacific Ocean. The other distinct population segment of gray whales migrates along the western portion of the Pacific Ocean and northern areas as well. The West Coast distinct population segment was previously listed as endangered by the U.S. Endangered Species Act, but reached large enough numbers to constitute delisting in 1994. Once again, link here for that information. Multiple subpopulations of humpback whales travel along the West Coast migration corridor from Mexico and Central America. Each of those are subpopulations. These subpopulations are listed as threatened and endangered by the U.S. Endangered Species Act. And then lastly, of the species discussed here, the harbor porpoise is the most vulnerable to human conflict because they inhabit coastal waters closest to land and therefore human activity. Harbor porpoises elicit the least management concern regardless of these high conflict counts and unknown population trends. Next, I have distribution density maps that I've made and included in this presentation. So we have blue whales listed here, gray whales, humpback whales, and harbor porpoises. Each of these clouds is a density heat map that shows the relative density, highest density of each species relative to their distribution along the West Coast. So we have, let's see if I can... We have the legend over here showing that any identified color is an area of relatively high density. Gray whales shown here, here, and here. Obviously, blue whales is easy to pick out. And then we have the inset map here showing the relative location of the study area to the continental U.S. Again, that information was collected from Duke University in the CMAP database. Next, I have the combined cetacean density and identified habitats map. The map above depicts the relative density of observations for all cetacean species. That's the heat map you see here with a number of different hotspots that are identified by the white-yellow sections. And then I also have habitat areas of particular concern on this half of the swipe feature. These were put together by the Pacific Fisheries Management Council. And then on this half of the swipe feature, we have the biologically important areas for cetaceans in U.S. waters. You can see that pink here shows biologically important areas for harbor porpoises. The blue sections are the BIAs for blue whales. Gray whales have a BIA that travels all the way up the west coast. They're a highly migratory species, and they hug the coast pretty significantly. Lastly, humpback whales with the green sections. These are largely areas that are important for humpback feeding. More detail on each of those data sets. Habitat areas of particular concern are areas designated by the Pacific Fishery Management Council. These areas provide significant ecosystem services and serve as habitat environments that require preservation and monitoring to maintain healthy coasts and oceans, along with the species they support. Biologically important areas are identified by the Cetacean Density and Distribution Mapping Working Group. BIAs are reproductive areas, feeding areas, migratory corridors, as seen with the gray whale, and areas in which small and resident populations are concentrated, like what we saw with the harbor porpoises. BIAs are region-specific, species-specific, and time-specific. So relative to the time of migration, this area, or the gray whale area, may not be all that important, but once it's migration season, it's very important. The next section of the story map is vessel impacts to marine mammals. Vessels interfere with cetacean behaviors such as communicating, resting, migrating, breeding, and feeding. This picture we have over here is a physical disturbance that a cetacean might encounter with increased vessel or just even a single vessel impact. This gray whale here, a humpback whale, unfortunately, bears some marks of contacting a boat propeller. Cetacean and other marine mammals experience symptoms of vessel traffic effects, such as acoustic and physical disturbances, environmental contaminants, and reduced prey availability. Simply the presence of vessels can result in noise pollution that impacts cetacean health and behavior and interrupts species communication. Vessel and boat noise directly overlaps with cetacean calls and hearing frequency. Before I move on, I just wanted to point out this infographic. Vessel noise and the different effects it can have on marine animals. I've already gone over some of those, but important to notice are the navigate and then mate and reproduce. Those behaviors can all be impacted. Before I go to the next paragraph, I wanted to bring up this infographic here. That shows, sorry about that, the frequencies of sound and how whales and cetaceans use it, and then how it's emitted by various boats and other marine vessels. So the large vessel noise basically spans all of the frequency range that we have shown here. But you can see how baleen whales here are the low to mid frequency, toothed whales, high frequencies, and then the porpoises in the high frequency. You can also see how much they directly overlap, as I said earlier. Also shown below is an infographic summary of West Coast crude and non-crude oil spills from 2019. Let me pull that up real quick. So this is the crude spill infographic that I was talking about. You can see that marine spills only make up 0.3%, whereas freshwater makes up the majority at 68%. This is important because before I move on, I want to show this one too. So freshwater here at 18%, marine at 17%, so that constitutes roughly 25%, a quarter of all the non-crude oil spills. Anyway, so these these numbers are important because in coastal ecosystems, such as the Pacific States and British Columbia, where this survey was conducted, the marine environment is directly impacted by the state of the freshwater environment. So we can assume that all the oil that's spilled in whatever water and habitat, aquatic habitat, will end up impacting cetaceans and other marine mammals. The last section I have here is Ais Vessel Traffic. The automatic identification system provides the U.S. Coast Guard with information on large vessel characteristics such as location, heading, and ship length, just to name a few. This raw data is processed for vessel traffic analysis by the Bureau of Ocean Energy Management and the National Oceanic Atmospheric Administration, and then is distributed via their joint database, which there's a link to here. The most recent 2020 annual dataset of vessel traffic was published in September of 2021, and the geodatabase includes commercial and recreational vehicles which either originated, terminated, or otherwise utilized or passed by one of the major West Coast ports shown in this map over here. I also have a wonderful video that I found on YouTube, and I've linked it here. It's not something I'm going to play for this presentation just because I am running short on time, but it goes into great detail on the benefits of AIS and how it helps both the ecological community and humans in general. The last bit of maps that I want to share are the 2020 vessel traffic by season maps that I've created. Took a lot of data management to get these into a suitable sharing state. Let's see here. Okay, so this map is going to show us the relative traffic density, which is the high density areas are designated by the white and light colors, the red color. This white feature compares the spring and summer densities. So here we have summer, which is a relatively high, you can tell that the density is higher here than in the spring. And then I also have a fall and winter density. So here's winter, here's fall. You can see a very dense number of vessels in these areas, the bright yellow areas. Lastly, I would like to share this map that I created. I can't get it to fit within the screen here, but that's okay. We have the number of tracks that overlap designated marine habitats. Each of these lines here represents an individual track. The ones on this map are the only, out of all of the AIS data for 2020, these are the only ones that actually overlap the marine, the biologically important areas and the habitat areas of particular concern that I discussed earlier. And what's significant about this is that I actually have a number here showing that fall, we have 700,000 plus vessel tracks that intersect or overlap with any of those habitat areas. So we can understand that that's relatively significant for any of the species that utilize those areas. In conclusion, vessels interfere with marine ecosystems in many ways. Marine mammals, particularly cetaceans, are vulnerable to impacts of high vessel traffic. The overlap of vessel traffic with habitats understood to hold significant resources for cetaceans is extremely detrimental to cetacean health. Thank you so much for listening to my presentation. I will include this list of references for anyone's perusal. Thank you so much, and I look forward to any feedback you guys can provide me.